So welcome back to the second video in our series where we're going to be starting to cover some of the basics of object-oriented programming in C++. Now, one of the things that are important to know when using objects is when you approach a programming problem in an object-oriented language, you no longer ask how the problem will be divided into functions like some other languages, but instead you ask how it will be divided into objects. So, for example, if somebody were to come give you an object like a computer and say you need to write a program on it, then you'd break it down into pieces. You'd have your case, your motherboard, your hard drive, your RAM, your processor, and so on. So, thinking in terms of objects rather than functions has a surprisingly helpful effect on how easily programs can be designed. This results from the close match between objects in the programming sense and objects in the real world. This process is described a lot more in detail in Chapter 16 of Object-Oriented Software Development. So when we get to that point, then we'll be able to go into more depth and have a deeper explanation of it. So now let's talk about classes. Now the match between programming objects and real-world objects is the happy result of combining data and functions. The resulting objects offer a revolution in program design. No such close match between programming constructs and the items being modeled exists in a procedural language. Classes. In object-oriented programming, we say that objects are members of classes. What does this mean? Well, let's look at an analogy. Almost all computer languages have built-in data types. For instance, a data type int, meaning integer, is predefined in C++, as we'll see soon in Chapter 3 when we get to loops and decisions. You can declare as many variables of type integer as you need in your program. In a similar way, you can define many objects of the same class. And classes serves as a plane or blueprint. It specifies what data and what functions will be included in objects of that class. Defining the class doesn't create any objects, just as the mere existence of data type integer doesn't create any variables. A class is thus a description of a number of similar objects. This fits our non-technical understanding of the word class. Now, inheritance, the idea of classes leads to the idea of inheritance. In our daily lives, we use the concept of classes divided into subclasses. We know that the animal class is divided into mammals, insects, birds, and so on. The vehicle class is divided into cars, trucks, buses, motorcycles, and so on. So what this means is in classes, when you're able to specify something as simple as an integer, you have to keep in mind that that integer that you're specifying, integer day, count, divisor, answer, is an object. The integer is an object, and that is an instance of the object, which is the class. So when you use inheritance, you're using something that has access to the object, but it's a subclass where it has something in common with that object, like vehicles are cars, trucks, buses, and motorcycles, and so on. So if we look at this object here, we see an object of one, a class foobar, class, then object two, class foobar, and object three. And this shows three different objects. Now the principle in this sort of division is that each subclass shares common characteristics with the class from which it is derived. And so cars, trucks, buses, and motorcycles all have wheels and motors. These are the defining characteristics of a vehicle. In addition to the characteristics shared with other members of the class, each subclass has its own particular characteristics. Buses, for instance, have seats for many people, while trucks have space for hauling heavy loads. So the idea shown here is we have a base class. A similar way, an object-oriented class can become a parent of several subclasses. In C++, the original class is called the base class. Other classes can be defined as that shares characteristics, but add their own as well, and these are called derived classes. So this is what inheritance is here. These derived classes are able to inherit features from the base class, but they also have their own private characteristics. So this is what's important to understand about object-oriented programming and classes and inheritance and derived classes. Don't confuse the relation of objects to classes on the one hand with the relation of a base class to derived classes on the other. Objects which exist in the computer's memory each embodies the exact characteristics of their class, which serves as a template. Derived classes inherit some characteristics from their base class, but add new ones on their own. Inheritance is somewhat analogous to using functions to simplify a traditional procedural program. If we find that three different sections of a procedural program do almost exactly the same thing, we recognize an opportunity to extract the common elements of these three sections and put them into a single function. The three sections of the program can call the function to execute the common actions, and they can perform their own individual processing as well. Similarly, a base class contains elements common to a group of derived classes. As functions do in procedural program, inheritance shortens in object-oriented programs and clarifies the relationship among program entities. Reusability. Now, once a class has been written, created, and debugged, it can be distributed to other programmers for use in their own programs. This is called reusability. It is similar to the way a library of functions in a procedural language can be incorporated into different programs. However, in object-oriented programming, the concept of inheritance provides an important extension to the idea of reusability. A programmer can take an existing class and, without modifying it, add additional features and capabilities to it. This is done by deriving a new class from the existing one. The new class will inherit the capabilities of the old one, but it's free to add new features of its own. For example, you might have written or purchased from someone else a class that creates a menu system, such as that is used in Windows or a graphic user interface GUI. This class works fine, you don't want to change it, but you want to add the capability to make some menu entries flash on and off. To do this, you simply create a new class that inherits all the capabilities of the existing one, but adds flashing menu entries to it. The ease of the ease of which the ease with which existing software can be reused is an important benefit of object-oriented programming, and many companies find that being able to reuse classes on a second project provides an increased return on their original programming investment. Now let's talk about creating new data types. One of the benefits of objects is that they give the programmer a convenient way to construct new data types. Suppose you work with two-dimensional positions such as x and y coordinates or latitude and longitude in your program, and you would like to express operations on these positional values with normal arithmetic operations such as position 1 equals position 2 plus origin, where the variables position 1, position 2, and origin each represent a pair of independent numerical quantities. By creating a class that incorporates these two values and declaring position 1, position 2, and origin to be objects of this class, we can in effect create a new data type. Many features of C++ are intended to facilitate the creation of new data types in this manner. Polymorphism and overloading. Now that the equals and plus operators used in position arithmetic shown above don't act as the same way they do in operations on built-in types such as int, the objects position 1 and so on are not predefined in C++, but our programmer defined objects of class position. How do the equals and plus operators know how to operate on objects? The answer to that, we can define new behaviors for these operators. These operations will be member functions of the position class. Using operators or functions in different ways, depending on what they are operating on, is called polymorphism. One thing with several distinct forms, when an existing operator such as plus or equals is given the capability to operate on a new data type, it is said to be overloaded. Overloading is kind of a polymorphism. It is also an important feature of object-oriented programming. So in our next video, we're going to get started and step into actually doing some C++ programming with object oriented to get some hands on and work our way towards really seeing the power of object oriented programming, working with derived classes, polymorphism, and encapsulation, and all of that good stuff. So if you're interested in the next video, head on over to youtube.com, check out our channel here at databasetutorials.com, and subscribe if you would like to be notified. So thank you for watching, and until next time.